This lab is called the density of solids. So this is what you should have in your comp book. Okay, all this, there's two tables down here. There's a third table we're not going to put in there. And this is all attached on Canvas. This is the stuff from the textbook. You can see there are 1, 2, 3, 4 blue questions here. And then there's 5 numbered questions here. These all need to be answered underneath the data tables in your comp book. So the easiest way to do this, we're just going to get started and we're going to fill in the data tables. You can write this stuff down as we go. Remember, we always measure one place beyond what the scale gives us. Our triple beam balance goes to the tenths place, so we're going to estimate to the hundredths place. And our rulers, we're going to use the centimeter side, and it goes to the tenths place, so we're also going to estimate to the hundredths place. So we have 2 cubes, okay? This one has a 1 on it, so this is cube 1. This is cube 2. And then we also have a slab and this is the slab, this is what they're talking about, and a rock. Okay, this rock just happens to have a number 2 on it for another lab that we use it for. So we're going to go through first, and we're going to fill out the first table. We just want to know the length, width, and height of the 2 cubes in the slab. So we'll start with cube 1. And since it's a cube, it should be the same on all sides, but we'll still measure it. It looks like it's almost exactly 1.2. So we'll just call it, we'll say the length is 1.20. And then the width, I'm just going to turn it this way. And the width is also 1.20. And the height, I'll turn it over here, is 1.20. So you should have 1.20, 1.20, 1.20. Then we're going to look at the second cube. We'll do the same thing. It looks like it's almost exactly the same, 1.20. The height is, let me get it straight here, 1.20. And then the width, we'll turn it this way, is 1.20. So it should be 1.20 on all sides. So for the cube, we'll say 1.20, 1.20, and 1.20. So we'll do the same thing here with the slab. We'll say that we'll just pick a corner. We'll pick this one here. This is the length, this is the width, and then this is the height here. So we'll do the length first. That's pretty close. It's almost 7.8. Let's call it 7.78 for the length. And then the width, is almost 2.5. We'll say it's 2.45. So 2.45 for the width. And then the height, or the thickness of it, looks to be about 0.6. So we'll just call it 0.60. And so then we can go down here and find the volume of the 2 cubes in the slab by taking length times width times height for each of them. The 2 cubes should be the same. The slab should give you something different. So you just have to multiply length times width times height. The rock's going to be a little bit different since it's irregular. We can't use the ruler to find the volume of it, so we're going to have to use water displacement. So I've already got a graduated cylinder with about 30 cubic centimeters, 30 milliliters of water in it. So we're going to slide the rock in so it doesn't splash. And it goes up to 34. So the volume of the rock is 34 minus 30, which is 4 cubic centimeters. Now we want to go back through and find the mass. So let's get this rock out of here. And so we'll just start with cube 1. We'll put it on the balance. And I'm sure it's not 10, but we'll check anyways. Oh, it is 10. So it's a little bit over 10. And from my point of view, it looks to me like it's about 15, a little bit past the 0.6, so we'll call it 15.61. So that's what's going to go here for the mass of cube 1, 15.61. Then we'll put cube 2 on, do the same thing. I don't think this is going to be 10, but I was wrong on the last one. Looks to me like it's about 5.35. So cube 2 is 5.35. Is what you'll put right here. And then the slab, same thing. I'm going to zero that out, put the slab on. Okay, so it's 30 something. It's almost 30.8. We'll call it 30.78 for the mass of the slab. And then we've got to do the rock too. So rock was in water. I probably should have found the mass first, but we'll dry it off real good. And then we'll put it on and see what we end up with for the mass of the rock. So it's not quite 10. So it's 8.92. So we'll put 8.92 for the mass of the rock. Remember to find density. We can take the mass divided by the volume. So you can go through and calculate the density here, this number divided by the volume. Then go back through and answer all the blue questions, all 4 of them, and then 11 through 15 as well. Make sure you write those in your comp book.